Hello viewers, in this tutorial we will try to know how to compute correlation coefficient in R and regression. So this is our data, and based on this data we will compute this. So our data set contains 20 observations and 2 variables. So let us plot a scatter plot to see the pattern of this data. So go to insert, then scatter plot. Okay, now we will select the data. Okay, so here we click add. Our series name, we can name it scatter plot. Our x values is our study hour, and our y values is our CGPA. So we click OK and then OK. So this is our scatter plot. Here the x-axis contains the value of study hour and the y-axis contains the value of CGPA. We can show the axis here by clicking axis title. We rename the title. Here is study hour, and this is CGPA. Okay, so this is our plot. Now to compute the correlation coefficient, we use the function correl, C-O-R-R-E-L, correl function. So click it. Now we'll input our first variable, that is study hour, and our second variable, that is CGPA. Okay, now enter. Okay, so the correlation coefficient of our data set between the variables CGPA and study hour is 0.71, and this is greater than 0.5, which indicates strong positive correlation between study hour and CGPA. So now we want to fit a regression line because we want to see the effect of study hour on CGPA, how much CGPA changes after changing the study hour. So let's click on the data tab. Now go to data analysis and click regression, then OK. So we will define our input range x and y. So we will input our y range, click here, and our y variable is here CGPA. I am taking the header also CGPA, and I put labels here so that the first row can be defined as header. Now the x range, the x variable or independent variable range here is study hour. Okay, and I want to use confidence interval 95%, and the output range, I want to see my output here. Click OK, and I want to see the fitted plot here. So click OK. Yeah, this is our result. So here the summary output of our regression line. Here the multiple R square is coefficient of determination 0.718, R square is 0.51, and adjusted R square 0.48. Here the intercept value, our intercept value is 2.16, and the beta value, which is our study hour, that is 0.2096. It means if we increase our study hour by 1 hour, then the CGPA will be increased by 0.2, and the intercept term, that is 2.16. So this is our fitted regression plot. Here the blue points indicates the CGPA original variable, which is original data, and the red point indicates the predicted CGPA or estimated value from the regression. So this is the way we can compute correlation coefficient and fit regression, linear regression here.